Alright guys, what we are looking at is this thing called a cool tool on the calculator. So I bet you haven't paid attention to this much before, but there is actually an app button on your calculator. So I'm going to pull my screen out here so you can see this. I want everyone to look right below the X variable key, and guys, it's been there all along. You have your apps button. Now I have a lot more stuff in here, but all of your calculators have the finance app. So we're going to apps, finance, and TVM solver. It's the first thing that comes up. And what it does is it does all the same work that would normally be done with this old formula that we've been working with. So instead of having two things multiplied together in the exponent, we actually just put that in as one number. So we multiply the n and the t here. The little n, the number of compounding periods that we're used to putting in, 12 for monthly, things like that, is what this little c/y is. So this is really what's happening. So I thought I'd play around with these two examples and show you how it works. You take your calculator, and so I would have a 10 in. This is just going to be mechanics on the calculator. I'm going to have 9% interest. You don't have to convert anything to a decimal. I'm going to have $5,000 here. Whoops, sorry, that's pulling up other things on the screen there. And then I'm going to go in this problem and say, what would my future value be? And this would be if I made once a year 9% interest, once a year over 10 years. My future value is, now here's the other thing, look down by enter. Do you see the word solve there? Mine's green, so I'm going to hit alpha, enter on that row. And this says if in 10 years I've invested $5,000, that's my payment. For 10 years at 9%, it would grow to be almost $76,000. The other example I have over here, we'll change it up again. What if I change my numbers, and there's no way to clear it all at once, you just kind of type over it. I'm going to put my 60 in. Oops, gotta raise my calculator a little. So 60, I'm looking at 6% interest here. PV stands for, just like it always has, present value. So you're starting with 25,000 in an investment. In payment, I'm going to have a 0 there. I'm going to be solving for future value, so I like to go to 0 there. And then this would be compounded monthly. Notice I just hit enter and it went there. So 60 means 12 times what gives you 60. So this is over 5 years. If I started with 25,000 at 6%, I want to see what the future value would be. I go to that FV row. I'm working with this word solve here. So alpha, enter, it would be worth $33,000. So kind of cool. Hope you find that interesting. Now we're going to use it on a couple problems. So in this first example, you have this lady Vanessa who's a financial planner. It says, in Josephine's initial situation, she plans to retire in 50 years with $1 million in savings. So if we use at least the current rate of inflation, which, guys, it's all over the place right now. I'm just going to make up 5.6. Let's just use it for now. So again, future value would be $1 million over 50 years. It's annual interest, so it's compounded once a year. Right? This is the formula that we use. And we would go into our calculator, we would solve for this, and we would come up with $65,584.93. Okay? But do you think people in the real world really go out and do this formula all the time? No. This is the same example that you see here in the chart in number 2. So if you tweak this information and you plug it in, I've got the calculator preloaded with this one. So again, where do you go? You go to Apps, Finance, TVM Solver. And what I have loaded in here says that her capital N, it tells you what it all is here. This is the number of compounding periods, so 50 years at once a year. 50 years at once a year. You want future value to be $1 million. 5.6 is the interest rate. You do not have to convert it. And it's asking how much money to put in now. So you put your cursor on the row that you're solving for, and then you go to, got to raise that up there, sorry, alpha, enter. And that does solve on the calculator. And lo and behold, it's the same, $65,584.93. So isn't that cool? So if you learn the vocabulary here, what you've been doing your whole life with this formula, this guy here, can now be done on the calculator, and lo and behold, you get the same answer. How cool is that? So something to think about. You may have noticed as this comes up that it's negative. And if you notice, you'll see the dot. If you look back at your screen, you're like, hey, which one did I solve for here? You solve for PV. It'll have that dot there. Again, using solve, that's down here by the enter key. Why it's negative, this is kind of a hard thing to think about if you haven't taken accounting, but hopefully a lot of you will take that in college. The idea is if it's cash outflow, if it's money that goes out of your kind of money that you're using, you are putting in 65,000. Therefore, it's a negative transaction in terms of your bank. You're putting it away somewhere so that it will grow to be 1,000. I don't need you, honestly, to be real concerned about the negatives, but you need to understand that that's what's happening. If you are putting money away, it's leaving your wallet. That's a negative transaction. So here's our next example, and we're trying to help Reginald. Reginald wants to find the future value of an investment of 6,000, so that's present value. If it earns 6.25%, compounded quarterly, so that's 4 times a year. Now think about that. That quarterly, 4 would go here. If it's 35 years, that capital N has to be 4 times 35. And he wants to find the FV, find the future value. Let me give you a moment to think through that, try to fill them in. Okay, keep pausing if you still need to work on it, but compounding periods per year. This is 4 times a year. Fun fact, we don't do anything with payments for a few days, I think into next week. Next week is when we do payments, so we'll keep a 0 there. These two will stay the same. Future value is what we're going to need to solve for. Present value is $6,000. And if you're stuck up top here, if you don't know what, again, the number 4 from the bottom, the 35 years from the top, you can type it in as a math problem. It will do that for you. And again, if you're putting in that 6,000, it is best if you made that a negative value. So things to think about in terms of what's going to happen. I'm going to do this 2 ways and show you something. So we're solving. We're trying to help Reginald figure out how much money he's going to have. So I'm going to go to alpha, enter, and solve. He would have $52,000. So that's a good thing to know. Here's what I want to show you. Remember this? I put the negative in here for PV. It ended up here with a positive 52,000. What if I had forgotten and I put the 6,000 in as positive? I want you to see that there's no panicking here. If I go in this direction and go alpha, enter, I get the same number, but the negative goes here. So the correct math on it is if you're putting money away, if it's leaving your wallet, that's a negative transaction, and then your future value would be a positive amount. But I just wanted to show you, if you forgot the negative, it's just going to come up in the other one. That is not a problem. All right? All right, now let's meet Hilda. She wants to have 10,000 in 10 years after investing in an account that earns 3.6% compounded monthly. Okay, compounded monthly is this guy down here. So 12 is your number of compounding periods. Compounding periods times years, so this would be 12 times 10, that's going to be 120. And the 10,000 is what she wants to have, so that's her future value. So if she wants to have 10,000, 3.6, no need to convert. The calculator does that. And remember up here that 120 is 10 years times this 12 from the bottom. So we're going to solve for how much money she needs to put in now, and she needed to put in almost $7,000 at that interest rate. So $6,980.52. All right, now let's meet Juan. Juan wants to put in $1,250. He has an account that earns 2.34% interest. It's compounded monthly. How many years is it going to take for that initial amount, $1,250, to turn into $5,000? So these are the letters. Now I'm pulling away the words now so we can start thinking about what goes where. And again, we are not working with any payments. This is just a one-time. He's going to put in $1,250. He wants it to grow to be $5,000. So think about where those numbers will go. Is this what you came up with? Now this is really hard, the part in orange, so I want to talk about this. The amount that he's putting in is present value. It's leaving his wallet, so I put that in negative. It's going to grow to be a positive 5,000. Compounded monthly is going to put 12s down here. But if it's asking how many years, and we go to the calculator and we solve, you're going to get this big number. That's not the number of years. N is not the number of years. It's number of years times compounding periods. So when you get this number down here, whatever was in this C/Y, compounding periods per year, you need to divide it out. So when you take your 711.6, let me do it here, sorry. Go away. When you take your 711.6 and you're dividing it by 12, because that's the number of compounding periods, you're going to end up getting the actual number of years. So 59.3 years is what it would take for it to grow. So the takeaway from 1 is that when you solve for time, you're not done when you do this line in the calculator. So you got to do one extra step, divide it by 12 to get 59.3 years.